Hi everyone, this is Mrs. Eggerding and this is Unit 3, Video 2. We are going to start our review of factoring, and what you see here should be pretty familiar from the things you saw in Algebra 1. We're going to start talking about the greatest common factor first. And what you may have seen in Algebra 1 is something like this, where what they have in common is the variable. And in order to factor that, you want to make sure you take out the lowest exponent. And so here the lowest exponent is y to the second. What you are left with is 9 y to the third. You took out 2 of the exponents, you have 3 left, plus, well, if I took out everything, I'd have y to the 0, which is 1. Nice thing about factoring with greatest common factor is if you decide that you're not sure about your answer, you can always take this and check it by multiplying. Either do it on the side, or you can go ahead and multiply. Do it on the side, or you can just go ahead and do it in your head. Y to the second times 9y to the third is 9y to the fifth. Y to the second times 1 is y to the second. Next one we have a little more complicated. 6x to the second t plus 8xt minus 12t. This one has a greatest common factor of both a number. They all are divisible by 2, and they all have a t. What you're left with, if I take out the factor of 2 from the 6, I'm left with 3 x to the second, plus take out the factor of 2 from the 8, you're left with 4x, and if you take the factor of 2 out from the 12, you're left with a 6, and you can call that done. Last thing we're going to take a look at, and this might be a little bit new, is something that looks like this, where the greatest common factor isn't just one term, but it is a quantity. So every single one of these terms has an m plus 1 in parentheses. That is your greatest common factor. You also do have to check the numbers, and they are all divisible by 7. So here my greatest common factor is a 7, and every single one of them has a factor of m plus 1. That's my greatest common factor. What I'm left with then, well, from the 14 I'm left with a 2. I took out one of the m plus 1s, so I am left with 2 more m plus 1s, minus, take out a factor of 7 from 28, that's 4. This was m plus 1 squared. I took one of them out, so I have m plus 1. And then I'm left with a minus 1. What happens on the inside now that I've taken care of that is some of this stuff on the inside here can simplify. So if I keep everything the same, 7 m plus 1, on the inside I have 2 m plus 1 squared. If I simplify this, I have minus 4m, and that's going to be minus 4 minus 1, so I have minus 5. So there's a little bit more simplifying you can do if you want. These are the kinds of greatest common factor you're going to see. The other kind of basic factoring we're going to review is the difference of two perfect squares. Now the perfect squares are things like 1, 4, 9, and so on. Also, you can use exponents. X squared is a perfect square because that's x times x. X to the 4th is a perfect square because that's x to the second times x to the second. X to the sixth is a perfect square because that's x to the third times x to the third. Remember, when you multiply, you add the exponents. So actually any even number is a perfect square. So I'll make that even because I can divide it in half and get x to the n times x to the n. We'll do a lot more with these other exponents in class. For now, let's take a look maybe from Algebra 1, one of your basic examples. All of these things in here are perfect squares. So when you have perfect squares, I can take their square roots, 2m minus 3n, and then the other factor will be 2m plus 3n. Here's one that has a quantity to the second power. So here is a perfect square, and then 25y squared is a perfect square. Use the same idea. I can take the x minus 3 minus 5y, and I can take an x minus 3 plus 5y. Last example, here's one where we have the multiple powers. B to the fourth, its perfect square is b squared minus 9c squared, and b squared plus 9c squared. Now you need to be careful on some of these, because if you notice, everything inside those parentheses are still perfect squares, so we can go ahead and keep going and get b plus 3c, b minus 3c. The addition, you can't factor the addition with perfect squares, so we'll just leave it as is, and this one down here is your final answer. So what we have for you is just some practice of what you saw here. 1 to 15 odd, that practices the greatest common factor. 45 to 51 odd, those practice the difference of two squares. And then 63 just asks you something more about the difference of two squares. Bring your questions to class, and we'll talk to you later. Bye.